Good afternoon, everyone. Let us take the number of density of conduction electrons is 9.5 into 10 to the power of 28 meter cube. Calculate the time taken by an electron to drift from one end of the wire 4 meter long to other end. The area of cross section of the wire is 1.8 into 10 to the power of minus 6 meter square and is carrying a current of 5 ampere. Okay, let us see the problem. This is a problem regarding with the drift velocity. That is here the number of density of conduction of electron is given. That is here density is given, and that is taken as n is equal to 9.5 into 10 to the power of 28. And also what we have to calculate here, we have to calculate the time, that is t is equal to question mark of an electron drift from one end to the another end. That is nothing but the length of the electron, that is L is equal to 4 meter, and area of cross section is given, that is A is equal to 1.8 into 10 to the power of minus 6 meter square, right? And I, that is current, carrying current I is also given, that is 5 into 5 ampere. Then charge, that is given by 1.6 into 10 to the power of minus 19. Okay, according to the definition, we have to take on that as Vd is equal to, that is I is equal to NeaVd, and we need Vd, now that is drift velocity, then that is given by Vd is equal to I divided by Nea. Then here Vd is equal to, substitute the value of Nea as well as I. The I is found to be 5 and N is 9.5 into 10 to the power of 28. Then E, that is charge of an electron, that is found to be 1.6 into 10 to the power of minus 19, and that is into A, that is area of cross section, 1.8 into 10 to the power of minus 6. Then take a 5 and simplify the 9.8 into 1.6 into 1.8. You are getting that as 27.36, and 10 to the power of 28 into 10 to the power of minus 16 and 10 to the power of minus 6, that will be 10 to the power of 3. And Vd is nothing, we will get 5 divided by 27.36. Then simplify this one, you are getting that as 0.1827 into 10 to the power of minus 3 meter per second. And also we have to find out the drift time. So take the definition, that is drift velocity is nothing but distance divided by time, and using this relation we can easily find out the time, that is time is equal to distance divided by Vd. Then t is equal to, we get the distance, that is separation is 4 divided by Vd is found to be 0.182 into 10 to the power of minus 3, and that is after the simplification, that is 4 divided by 0.182, that is found to be 21.97 into 10 to the power of 3, that is time, that is in terms of second. Okay, let us move with the next problem. That is, an electron is moving in a beam as aperture of 2 into 10 to the power of minus 6 meter square. The total number of electrons moving through a perpendicular cross section per second is 6 into 10 to the power of 16. What is the current density in the beam? That is here we have to calculate the current density, and here they have given the D, that is D is nothing but 2 into 10 to the power of minus 6, and then is also given, that is 6 into 10 to the power of 16. And what we have to calculate, we have to calculate the current density of the beam in time t is equal to 1 second. Then according to the definition of current, we have to take in that as I is equal to Q by T. Then here Q will become E into N. Then I is equal to E into N divided by T. Then the value of E is found to be 1.6 into 10 to the power of minus 19, and N is given that is 6 into 10 to the power of 16 whole divided by 1 second. Then make the simplification of 1.6 into 6, that is found to be 9.6 into 10 to the power of minus 19, that is a plus 16, that is found to be minus is a greater sign, that is minus 3. Then current density is given by J is equal to I divided by A, and substitute the value of I here, that is we get an I, that's 9.6 into 10 to the power of minus 3 whole divided by A is given, that is 2 into 10 to the power of minus 6, and 9.6 divided by 2, that is found to be 4.8. 10 to the power of minus 3 divided by 10 to the power of minus 6, that is found to be 10 to the power of plus 3 ampere per meter square. Thank you. Welcome back again. And the next question is like this: the potential difference of 200 volt is maintained across a conductor of resistance 20 ohm. Calculate the number of electrons flowing through the conductor in 1 second. Here they have given a potential difference maintained across the conductor of resistance 20 ohm. We have to calculate in 1 second. That means we have to calculate a number of electrons E. Then here the given is potential difference, that is nothing but V, that is given 200 volt, and also R is given, that is a 20 ohm, and T is found to be 1 second. Then according to the definition we can take the directly the Ohm's law, that is V is equal to IR. Then using this we can easily find out an I, that is I is equal to V divided by R, that is found to be V is 200 divided by 20, that is found to be 10 amperes. Then according to the definition of the current, I is equal to Q by T, then we can write that as I T is equal to Q. Then here I value we know that as 10 amperes and the T value is 1 second, and we are getting that as Q is equal to 10. Then N is equal to IT divided by E. Then N is equal to I is found to be 10 and T is 1 second divided by the number of charge, that is charge of an electron is found to be 1.6 into 10 to the power of minus 19. Make the simplification of 10 divided by 1.6. We are getting that as 6.25 into 10 to the power of 19. Okay, let us solve the problem regarding with the resistance. You are provided with a 3 resistor, each of value 4 ohm. In how many ways we can connect them? Calculate the effective resistance in each case. Then in this type of problems they have given a 3 resistors with the values, that is here they have given a each value of 4 ohm. Then we have to construct, we have to design how many times we can connect with each resistor. Okay, let us solve the problem. They are series, that is here they are connected in series, means we have to take the effective resistance as an Rs is equal to R1 plus R2 plus R3. Then all values are same, then 4 plus 4 plus 4, that is Rs will getting a 12 ohm. Okay, in the same way if you taken the parallel for a 2, then that is taken as Rp is equal to R1 R2 divided by R1 plus R2. Then 4 into 4 divided by 4 plus 4, that is a 4 into 4, that is going to be 16, and 4 plus 4, that is going to be 8, that is 8 ones are 8 twos are. Then look at the, observe the figure here, this is in series and this is in parallel. Then here the question is calculate the effective resistance in each case, that is we have to calculate an effective resistance in each case, that is we already find the effective resistance, that is for a second case we are taking, that is Rp, that is equal to R3 Rp divided by R3 plus Rp, that is R3 is found to be 4 but Rp is found to be 2, just we calculate the P. Then 4 into 2 divided by 4 plus 2, that is 4 2 is 8, divided by 6, that is found to be 1.33. That is Rp is found to be 1.33. Then Rs is equal to R1 plus R2. Then Rs, we have to take in the series for the second design, that is like this. That is R1 and R2 are series, and that is connected R3 with the parallel, right? Then Rs will become 4 plus 4, that is equal to 8. Then Rp is equal to Rs into R3 divided by Rs plus R3. That is Rs is found to be 8 and R3 value is 4, and then 8 4s are 32 and 8 plus 4, that is equal to 12, and we are getting that as Rp as 2.66 ohms. Okay. Then in the same way we are connecting like this. There is a R1 and R2 that are in parallel, and that is R3 is connected that with a series connection. Then R1 R2 divided by R1 plus R2, that is 4 4 is 16, 4 plus 4 8, that is 16 divided by 8, that is found to be 2. Then effective resistance Rs is taken as an Rp plus R3, then that is equal to 2 plus 4, that is equal to 6 ohm, right? Thank you. Okay, let us take the last problem of this class. The resistance and of diameter 0.09 millimeter is 40 ohm. What is its specific resistance? This problem is regarding with the specific resistance. Then they are given a length of the wire that is found to be 0.6 meter, and D is found to be diameter, that is 0.09 millimeter, and R is a radius, and that is taken as a 40 ohms. Then according to the area, A is equal to pi r square. Then here R is nothing but they have not given a radius. Instead of giving a radius, they have taken a diameter. Then we can write that in terms of diameter, that is a R 2R is equal to D. Using that relation, we can write that as R is equal to D divided by 2 whole square. Then substitute the value, that is pi is found to be 3.14 and D is given, that is 0.09 in terms of millimeter they are given, then that is 10 to the power of minus 3 meter divided by 2 whole square. And make the simplification, that is a 0.9 divided by 2, that is found to be 0.045 into 10 to the power of minus 3 whole square into 3.14. Then make the square of this whole thing, that is found to be 0.002025 into 10 to the power of minus 6, and that is multiplied with 3.14. You are getting that as area as 0.006385 into 10 to the power of minus 6 meter square. Then according to the definition, rho is equal to RA divided by L. Then here A is nothing but the area of cross section, and that is found to be 0.006385 into 10 to the power of minus 6. Then substitute the value R, that is 40 into A, that is just now we calculated, that is 0.006385 into 10 to the power of minus 6 whole divided by 0.6. Then make the simplification, you are getting that as 0.4239 into 10 to the power of minus 6. And if you take in the we can write that in terms of 10 to the power of minus 9, then that is found to be rho is equal to 423.9 into 10 to the power of minus 9 ohm meter. Okay, I hope all you understand the this class. Okay, follow back the class. Thank you.